If you've ever written a for loop in Python, you have used an iterator. It feels like magic. You hand Python a list and it just flawlessly hands you back one item at a time until it's completely done. But if I asked you to explain exactly how that loop works under the hood, could you? Previously, we broke down how Python variables store data in memory. Today, we are looking at how Python moves through that data and understand the Python Iterator Protocol. So with all that said, let's get started. To get to the heart of this, we first need to clear up the biggest point of confusion, the difference between an iterable and an iterator. They sound the same, but they have entirely different jobs. Think of an iterable as a music playlist. A playlist is just a collection of songs. It doesn't play the music, and it just holds it. In Python, your lists, tuples, dictionaries, and even strings are iterables. They just hold the data. An iterator, on the other hand, is the music player itself. The player keeps track of exactly what song is currently playing. When you hit the next button, it knows exactly which song to load. And you can't play music without the player. So you can't iterate through the data without an iterator. If you're coming from the JavaScript world, you might be used to slightly different kind of loop mechanics. But Python handles this beautifully with two specific Dunder or double underscore methods. Together they form the Iterator Protocol. So we have two rules. Rule number 1 states that if you want to go from a playlist to a playing song, you need the iter method, the double underscore iter method. When you pass an iterable into Python's built-in iter function, it returns an iterator object. Rule number 2 is once you have that iterator, you can use the double underscore next method or the built-in next function to fetch the next item. The iterator remembers its state and it knows exactly where it left off. Let's prove this by writing a for loop from scratch without actually using the for keyword. Watch this. But what happens when the playlist is over and we hit next again? It doesn't just return none. It actively raises an exception called StopIteration. This exception isn't an error, it's a signal. It's the iterator's way of telling Python, hey, we are out of data, shut down the loop. So when you write a standard loop for Python or standard for loop, Python is actually doing this behind the scenes. That while loop with the try except block, that is exactly what your for loop is doing for you automatically. So why should you care? Why not just stick to list for everything? Memory efficiency. When you're building full stack applications, maybe fetching thousands of records from a database to eventually serve a front end, you do not want to load all the data into your server's RAM at once. Because an iterator only calculates and yields one item at a time, it uses a tiny predictable amount of memory, regardless of whether you're processing 10 items or 10 million items. This concept is what we call as lazy evaluation. So once you understand the iterator protocol, you unlock the ability to write custom iterators and even better generators, which we'll cover in the next video. So if you like this video, then hit the like button, and if you're new to my channel, hit the subscribe button and press the bell icon so you never miss an update, and I will see you next time.